Now, here's your speaker.
How's it going, Composability Summit attendees? Today we're going to be talking about composable SDLC security and securing the composable software supply chain. So you might be wondering, what's the problem with security right now? Well, we've narrowed it down to four main aspects that we'd like to focus on for this talk. First and foremost, security doesn't gather data directly from the tools within your SDLC. It might look at some of your tools as standalone entities, e.g., looking at your source code or other parts, but it doesn't look at your tools in aggregate. In addition, because of this, these point solutions that currently exist missed context, and that results in false positives and false negatives. We'll go into that in a little bit more shortly. Additionally, a lot of security tools are time intensive. Certain types of scans can actually last hours. And in addition, these scans have to be rerun each time you want to have an updated picture of your security. So it ends up falling out of sync with the actual state of your security quite often. And additionally, there's usually the issue of incomplete inventory. Most security solutions look at particular parts of the SDLC, but they don't look at every part of the SDLC. And a lot of attackers are exploiting this fact. We are seeing software supply chain attacks rise quite a bit. Software supply chain attacks in this context usually refers to a organization being attacked through one of its own dependencies, entities, tools that it uses, or other components. I think most people are familiar with the Log4j attack if you're watching this particular presentation, and I think that one epitomizes the absolute worst case scenario for a dependency-based software supply chain attack. But in the case of, say, CodeCov, it was actually tools that were used as the attack vector. And Gartner predicts that by 2025, about 45% of organizations worldwide will have experienced attacks on their software supply chain, which is a threefold increase from last year. Attackers are also shifting priorities from production apps to software delivery pipelines and even the developers who develop your software. By developers, it doesn't necessarily mean the actual people, although it certainly can. There's malicious actors out there, right? But developer accounts are frequently targeted because often they have heightened credentials, and these credentials are considered the crown jewels of the software supply chain because of the lateral movement they afford. And I think I just explained partially why attackers are shifting priorities. But one of the main reasons is that securing development tools is often an afterthought. Feature velocity takes precedence. In some organizations I've worked at, speed has often been the priority. And there's a lack of security visibility into new technologies. Oftentimes, there will be a prioritization of utilizing a newer technology or dependency or library without giving a complete scan into it, simply because, well, it affords the developer more opportunity to improve their velocity. And the tools to help uphold AppSec have not kept up with SDLC innovation. We currently have a state of AppSec alphabet soup, as we like to say. Point solutions such as WAF, SCA, DAST, RASP, SAST are often used, but because of the issues that I talked about before, such as them being point solutions that don't look at the entirety of the SDLC, they are plagued by false positives and false negatives.
Yeah.
So
And
supply chain
actually,
attacks.
sorry, Tony,
By
go
all
ahead.
means. By all means. I was really just leading to, since software supply chain attacks are composable, shouldn't security be composable?
Yeah, it makes sense. I mean, what I was going to say earlier was just that a lot of the tools that we're using on the security side are designed to understand what's happening, and they're designed to be run by the security teams. But especially in modern application development, a lot of times the tools that are used for the development, the repositories that are being used, the CI/CD pipelines, all of those tools a lot of times are being chosen and installed and configured by the development teams, like you said, to help the development teams be more productive and to increase that
Absolutely.
release velocity. And a lot of times the security teams don't even have access to any of that stuff. They're not part of the configuration process. And that can really lead to a lot of these problems. There's just kind of that disconnect between the left hand and the right hand. And both of them have very
Absolutely.
important goals, but you end up having gaps that can create these problems that we're about to discuss.
Exactly. The lack of security and the siloing is data, or siloing of data, as we like to say, is ultimately responsible for this lack of insight that we're seeing plaguing the SDLC. And we like to call the current state of affairs security whack-a-mole. Security solutions simply address issues as they are found, but we think that there's an improvement on the current way that things are done in this regard. Our solution is composable SDLC security. And you might be wondering, what does that mean? Well, the modern software deployment pipeline is bespoke. Think about it. Think about all the components needed to actually deploy a piece of modern software. Obviously, you'll be using an SEM source code. Imagine it like, say, GitHub, Bitbucket, even Garrett if you're about that. But you'll be using a custom build system as well, such as, say, Jenkins. You'll be using probably a registry or a container registry as well. Also, alerting software, ticketing software like Jira. And frankly, you can have security vulnerabilities emerge in any part of this. So it makes sense to integrate directly in that case. Each component introduces capability and vulnerability, as one of my wonderful coworkers actually just posted an article on and has given several talks on. GitHub Actions actually has been used as a vector of attack, or has a capability of being used as a vector of attack. Uh, and his work will probably explain it a bit better than I can. But this component does introduce a vector of attack that an attacker could potentially exploit. In addition, each service adds attack surface with each handoff of data between one service to another, say from source to build, leaves an opportunity for a man in the middle attack of sorts, or potentially even just for credentials to be left in plain text. Logs, I mentioned before, are important to watch on sheer principle of, well, if hard code secrets can emerge in your source code, could they not possibly emerge in your logs too? And then if an attacker has access to your logs, could they not potentially use that as an exploit or as their vector of exploit? Moving on, security posture is only as strong as the weakest link. Um, I touched on this just now, but all these handoffs of data provide a individual vectors of attack for potential interception, tampering, or other nefarious activity. Helping secure each individual surface helps secure the overall software supply chain. By saying all of that, do you have anything that you'd like to add on this one, John?
Sure. I mean, yeah, if you go back to the previous slide as well, one of the big advances with modern development approaches like DevOps is that we're creating all of this automation that helps move code. Just the developers focus on the code, they edit the code, commit it, and as soon as they commit the code, we create all that automation that kind of pushes it through the build process, the packaging process, stuffs it out into your registry, and then possibly triggers some sort of a deployment or delivery script that puts it out into the runtime environment. And that automation is one of the things that really creates this increased attack surface, because simply by changing code, the attackers can leverage the fact that everything is automated after that to get the code that they commit into the production environment without having to compromise all the pieces along the way.
Absolutely. We've even seen some instances of, I believe, domain takeover and chain jacking are the names of these particular attacks. But we've even some instances of attackers actually just purchasing actual libraries from actual developers. I believe not exactly a software supply chain attack, though it could have been, but the Great Suspender, which is a really popular add-on by Google Chrome, had that exact attack happen to it. A nefarious developer purchased it from the original development team, and then suddenly everyone using that add-on on Google Chrome had a 0-day vulnerability. It's something that takes surprisingly little effort and has an incredible return on investment. So that really explains the first part of why we should implement composable security. But getting into some of the additional benefits, we maximize oversight into services, I guess surfaces too, but um, maximizing this oversight helps prevent any data from being, say, tampered with without any sort of oversight. It prevents vulnerabilities from going unpatched. It creating this complete asset inventory provides a huge number of benefits for security. We believe that visibility equals security in that way. Ensuring data integrity between services is integral to this as well. Enabling visibility into development tools helps prevent them from being used for attack. In addition, breaking down the security data silo or breaking down security data silos to create better, more accurate results and fewer false positives is another humongous reason. And what I mean by this is typically data from development tools is sort of trapped in that particular development tool. And one of the best ways to actually create more unique and useful insights are to look at this data in a complex manner that actually compares data from multiple points to potentially identify instances of tampering.
Yeah, I mean, it's
Monitoring. Oh,
that
yes.
that's actually a key point. I think there is that like security findings in isolation. If you have a security tool that looks for hard coded secrets and it tells you that you have a hard coded secret, in your source code somewhere, say, it's really hard to know what to do with that information because you don't necessarily know how is that application being used or how is that code being used, that component. Is it being deployed into the production environment? Is it just being used as some sort of a testing tool or in a testing environment? And so just being able to understand that context of this is where a particular problem was found, but being able to kind of take a step back and look at the bigger picture of what does that really mean? Where else is it being used in the development process or in the production process, and how is it being used, and what data does it have access to? Is really important from a security perspective to be able to just understand that context so that you can break out of that silo of just being within the code and understanding how that code is being used elsewhere.
Absolutely. I think a very real example that some individuals watching this might understand is, let's say you have a Kubernetes deployment that is publicly viewable, the container is publicly um, viewable, etc. But for some reason, this deployment originates from a repository that is set to private. Chances are that could be a security misconfiguration because that disparate setting it should trigger some sort of alert. A lot of tools that only look at an individual service, however, would have no way of knowing about this potential vulnerability because, well, it involves looking at data between multiple different tools that are a couple of steps away from each other in the deployment pipeline. In monitoring these deployment and development tools directly rather than security data from, not to pick on these tools, but in Singularity, SAST or DAST results in much, much fewer false positives. The false positives that I've mentioned several times, I believe, are what really ruin security tools because if you're having an extraordinarily number of false positives, where's the time savings in that? Where's the benefit to your security teams if 90% of your alerts are false positives? Then, well, you're basically just training your developers and potentially your security team to ignore errors. I think of this one anecdote about when I worked at a large company that I won't be saying by name here, but the team I was working on really abused Splunk to the point that I had to create an entirely separate email folder for the, not exaggerating, about 120 emails that came in per day from those services just to make my workflow usable. Where's the benefit of having the tools if you're um, putting developers in a situation where they're inclined to do that? It just doesn't make sense. And by making better alerts, we provide improved alerting capabilities. Knowing exactly where the security vulnerability is and knowing in advance who has ownership allows for alerts to be pushed to very specific individuals. flaws in app-specific IAC will be uh, pushed to the code owners of that particular development um, place. And in addition, um, say foundational IAC, well, that would probably be pushed to a different team. By providing more context with your alerts, you're able to send the alerts to the relevant parties. And as I said before, prevent those false positives, not just for errors that don't need to happen, but alerts that you are not responsible for. So that begs the question, though, how do we implement composable security? We've been touching on it for most of the time, but we believe it involves integrating with each part of the SDLC in order to make it possible to gather these insights in the first place. Going through these particular parts, the first part is source control. You need to integrate your source control into your security solution as a baseline for tracking what changes are made, what people have access to your code, what IAC exists, what configurations you have, etc. Next up, we want to implement your build settings into security solutions because that allows you to see what source code was handed to you, what particular, and approach the exact same thing, who has access to these scripts, who knows what's supposed to happen within this. Next part is you want to connect your container registries because this will, as Artifactory users will know, registries sort of serve as a single source of truth for a lot of your artifacts. In addition, you're going to want to connect your cloud and infrastructure. This is very important because this helps you track exactly how your deployments look in the wild. Um, and chances are, if someone deploys a crypto miner on your infrastructure, you probably want to know about that. I have many a funny tangent about that, but moving on. You also want to connect your alerting services. And this one, I believe, seems a little bit less obvious, but thinking about it for a moment, if hard-coded secrets can emerge in your build pipeline, they can emerge in your source code, they could even exist in your registries. Chances are they could probably exist in your alerting systems as well. And while you might not think this is a big deal because, well, only the developers see this, it's still a violation of the principle of least privilege, and frankly, it's reckless to not want to be aware of what sort of um, issues might be exposed within your alerts. So, in addition, integrating with your alerting services allows for any sort of alerts to be very specifically pushed to certain individuals depending on where the security violation occurs. And lastly, we want to integrate your issue tracking for the same reasons as alerts. You could have hard code secrets or other credentials emerge within your Jira tickets or Asana tickets. But you also want to make sure that issues are tracked appropriately and are not being lost to space by any sort of friction. And yeah, that we believe that composable security equals complete coverage.
Yeah, and I think one of the interesting things about this notion of composability is when, well, there's obviously the composability aspect of building the application that we're building with, the microservices or whatever other components go into the application itself. But we're also taking those same practices and extending them into the development process itself. So many teams are choosing their own repositories for their source code and their own pipeline tools, and each of those tools are going to have their own strengths and weaknesses, and there's not a lot of consistency in terms of what their capabilities are. And one of the nice things about this notion of composable security is that it doesn't really matter what an individual tool is capable of, as long as it's fit for the purpose that you're choosing it for. Things like security and getting these alerting integrations and being able to understand how it's being used in the broader process can all come from the
Absolutely,
security platform rather than the individual tools. And so you're
definitely
not really
something I
sacrificing the security capabilities, I guess, simply by choosing arbitrary development tools.
absolutely. Something I think that I may have missed earlier is that SAST, DAST, and other security tools definitely belong within your composable security stack. However, these tools should be thought of as just parts of your overall composable security solution. They are not standalone tools, but they can certainly provide very valuable data that can help, as we said, reduce false positives and improve the security capabilities of your organization.
Yeah, one of the things that's kind of been bouncing around in the back of my head is this. I'm starting to think of security for composable applications almost like APM, right? Where you can take your well, you have lots of fine-grained activities and tools that are operating within the development process, but the security tool really helps you get that 20,000 foot view of not only what's happening in specific pieces of code, but how that relates to things that are happening kind of throughout the broader application lifecycle. So you may have something that's happening in code. Maybe you find a potential vulnerability, and the security tool can help you understand where that code is going to be deployed and what container it's going to be put into and which developers are responsible for it. And so the security platform almost becomes like an application performance monitoring tool, which can stitch together all of that stuff and really give you that visibility so that the developers don't necessarily need to worry about that directly, but the security team is very interested and they get the visibility without having to spend lots of time interviewing developers to figure out how all that stuff is working.
Absolutely. And the best part about composable security tools is because they are more accurate, they don't waste developer time, but often they can actually be used to resolve security issues before they become larger security issues. Solving these issues early, the whole shift left idea that we've heard pretty often, really and truly does help prevent downstream issues from snowballing into larger problems that either need much more oversight to resolve or just more time to even diagnose in the first place.
For sure.
Yeah, that's and yeah. Thank you for coming to our session, everyone. We appreciate your time today, and yeah, please visit us at psycode.com to learn more about our composable security solution.
Hey, thanks so much for watching. I really hope you got some value from that. By the way, if you want more where that came from, we want to invite you to be a part of our community. Go to composability.dev and register today. If you've already registered, you know what I'm talking about. And by the way, if you're on Twitter at all, go to JavaScript Jam and follow us. Why? Because every Wednesday at 12 p.m. Pacific Standard Time, we go live. Yeah, live on Twitter Spaces. And you can join us and be with us there while we're live. Heck yeah. You know what? And it doesn't matter if you're a beginner or you've been doing this forever. We love everybody being involved. We bring so many people up to the stage. We have so many great conversations. We want you to be a part of it. All right. We'll see you there.